All right, class. So we've built this little joystick operated RC with our motor controller, our Arduino attached, our battery pack, and our little joystick that we've worked with before. Originally, we found the center to this joystick, as in the center position based off of there's two potentiometers on here. You have one on this side and one on that side, X and Y. And we found the resting center place because it's not exactly what it's supposed to be, about 512, 511, somewhere in there. Remember that potentiometers are that 0 to 1032 range. And with that said, the center we have to know so that we can actually control this car so it doesn't actually drift. So that's what we originally did when we actually found this. So this thing doesn't actually drift. Now, this we're going to have to end up programming. And I started a little sheet right here with kind of the big idea of what we're doing, our wiring, and our notes here. I'm going to end up doing some file save here. So I'm going to do a file. You can start with a new sketch. You don't have to start with it. You can start with the sketch where it's just Control X. You'll have just that, right? Control V. Control X is cut. Control V is copy. So just wanted to point that out because I use those a lot, and I think I mentioned those a lot in class. But I'm going to do a quick file save here. File save. And then I'm just going to call this Joy RC. And take a quick second. I'm actually going to zoom in here. That might help you a little bit here. 1, 2. All right, and so I have just the basic comment section right here in this, so that all these lines are commented out, so they won't run as code. They are just comments for us to look at. So we have our two-wheel RC car with our H-bridge, that's L298N, which is this little chip right here that we wired up. And the big idea is that we want this thing to have speed as we go forward, the magnitude of which we put into the joystick. And then we also want it to have left, right, forward and back. And then we also want to do a mix. So just like how a tank operates, where one wheel would go forward and one wheel would go back. So our thing can go like this and pivot. So that's the basic idea. What we're trying to program here is taking joystick data, output it through the little microcontroller, which is our Arduino, into the H-bridge, and then the H-bridge will run the motors in which directions we actually tell it. So our basic wiring for that joystick is we have our RX to A0, our RY to A1, a 5 volts to 5 volts, and ground to ground. And then we have our pin out for our H-bridge. We have to make sure that this is correctly wired with ENA and EMB into D6 and D5. And the reason why is because those are PWM, and we are doing magnitude of the joystick input relative to our speed. So the more we push forward on this joystick, boom. So just like that, the faster it's going to go forward, right? And then we have our basic other wiring for power. We have battery positive, battery negative, to our ground, and our Arduino ground as well required. And then I actually don't have it here, but we have another, I don't know how I forgot that, Arduino power as well. Control C. And we are not running 12 volts. We're actually running 5 volts here. I don't know why I put that 12 volts, but Control Z. We were just running the 5, 6 volts from the battery pack itself. And this is fine. Yeah, so we can't run the power from the Arduino, but we're running the power from the power pack. All right, so we did our basic calibration. My center was somewhere around here in a previous code. We all wrote that down, right? The X and Y basic center of our joystick on a different code set, so we can just find that center. We're going to put those into variables, which we're going to call center X and center Y. And then later on, if this still creeps, we're going to create a variable to hold a dead raw area. We're originally going to set that to 10, but if you find your vehicle, like the motors are slightly kicking on, or it's actually creeping forward or anything like that, we can end up increasing this dead raw data in, so it can create a larger dead spot in our joystick, just in case we actually didn't get this 100% correct, or if it's floating for some reason. All right, and then so then we have our basic math. Obviously, we're taking in raw data from that joystick, which is the 0 to 1023. And we want to subtract our center, and then we also want to convert that to the said 0 to 255, because on our PWM we have duty cycles and we have that set 0 to 255. In this case, we are actually going to say, hey, take in this data and map one direction as a positive 255 and map the other direction. So if I'm centered, right, we're going to map one direction. If I go that way, a positive 255, and then we're going to map the other direction this way, and negative 255. And so what that's going to do is essentially right down here, we're going to scale that right there, positive or negative, so that we end up having that data. It can easily tell us, oh, it's going to go forward or backwards or left or right, based off of that direction. So the sign, whether it's positive or negative, is going to dictate the direction, and the magnitude, which is 0 to 255, is going to dictate our speed, right? And then we're going to do a mix where a left is a forward and a turn, and a right is a forward minus a turn. So that's where we can do the tank thing, where one wheel will spin forward, one wheel will spin back. All right, so that's our basic idea of what we're going to do here. We're going to run over the same code as essentially what we did in class, and I'm just going to write that all out. I'm going to try to explain it the best I can to you so you understand exactly how we're stepping through everything, and we'll go from there. So, all right, let's go ahead and get started. We have our save program. It's going to automatically save because we have that set up in our preferences. All right, so basic start here. We got to start with a bunch of different variables. We have to establish, hey, we want to call our XY that we have plugged into A0 a said thing. We want to also, all those pins we have plugged into our Arduino here, we also want to label those and call those a said thing, right? And so that's where we start out with labeling things and kind of giving it those numbers, AN or EN, IN1, IN2. And remember, all of this is capital sensitive, or we're going to use these again, so you have to kind of remember what they're called if we label them something different up here. But remember, everything's capitalized or not capitalized. You have to continue that delineation throughout the whole entire code itself of how you actually call that out, right? Just want to point that out, right? So int, we're going to start with int, and we're going to start with those two X and Y. So that was the VR, I'm going to go, VR X equals A0. Close that. Int VR Y equals A1. Right, close that. And so those are our joysticks X and Y, which is going to be turn left and turn right. And then our joystick Y, forward and back. All right. So you can see that. All right, so then next we have to do our pinout for our H-bridge, which we have plugged in. And so that's our, I think there's six things there. So we have to do int, int, ENA. I'm going to do it uppercase. I'm going to do 5. We have to remember out the whole entire pinout, which is just right up here of how we actually pin that out. We closed it. I'm going to do that all the way down. I'm going to go int. All right, so Control C, left motor, right, and then just to make this a little fancy and dancy, I'm gonna go like this. I'm gonna go tab that in. You can highlight something like that and hit tab. It can tab everything in. It can look a little bit more decent. We're gonna say up here, we're gonna say And then I'm going to do this too as well. I'm going to say tab. Just kind of give us a little organization there, make it look decent. And then after that, we have our pinout for that. So we have those values in which we measured before, which was our center. And so that was put that right below here. I'm going to put some space so that we have that. Right, I'm going to go like this. Again, I'm going to tab that just one more time so I can make that look decent. Right, and so we have our pins for our H bridge. We have our pins for our joystick that we're naming. We're just naming pins. We aren't going to tell. We have to remember, we have to establish what those pinouts are in the pin mode down in the setup. But we're just naming those so we can call those up easier so we don't have to remember, oh, EN goes to pin 5, ENA or EN6. Or ENB goes to pin 5 and 6. You'd have to remember that whole entire thing. But if we just label it, we know we can look in the code and be like, well, we labeled it ENB because that's what it is. We can call that up. We don't have to remember all of the numbers, right, of that pinout, right? So that's what we're doing here. We're just labeling things. And now we have to take in that center of our joystick, and we called those. We said we're going to call those center X and center Y up here. Int. Let's see. I'm going to do an underscore. It has this, it came up like that and prompted me to it because I have my other code opened up on another screen in which I already wrote all this stuff. So that's why it's popping up like that. Normally it wouldn't pop up like that. But set equal to, what was mine? Let's see, 505, right? 505. And then we can essentially say copy. You could hit here and copy and hit paste like that, right? Or I can highlight this, Control C, Control V, and then all I'd have to do is change Y here. Do it uppercase. And then that was 18, right? 18, right? And so that's just a little trick there. Control C, Control V, copy and paste, or you can highlight something, left click with the mouse, right? You just highlight it instead of normal click. Right click with the mouse, and you get this little thing. So you can actually say copy and paste. But just wanted to show you that as well. All right, so we've established that we have our center for X and our center for Y. All right. Now the next thing we have to do is we have to do the optional raw data dead zone. And I'm just going to say go like this. We're going to say optional. You don't really have to do this, but I'm doing this just in case. I would highly recommend that you follow along here and do this thing because it's just simple. It's just another thing we have to add in. Dead. I'm going to do underscore raw. And I'm going to set that equal to 10. So we just have that little tiny 10 dead zone. If your car does creep, I want you to state that, yeah, you can hear. If it does creep or if the motors are kind of engaging, we can bump this up, right? So that's just an optional little thing we're adding. And then we have to do a quick flip in direction. So here, this is just some Boolean. This is inverts the axis if we need to. But here, this is something we haven't done before, but just follow along. It's called a bool. And we're going to call this invert underscore turn. Set that equal to false. So Boolean or bool is true or false, pretty much true or false. We'll maybe eventually dive deep into Boolean and bool and all of these other functions that we haven't touched on before. But for now, just write this down as false. And we're going to do the same thing for forward. So bool invert underscore FWD for forward equals false again. All right. So now we have that established. The last thing we have to establish, this is just a little extra thing we're going to do. we're going to do max PWM. And we're going to set our max PWM. We always can come back to this and actually make our car slower if we wanted to, because we're just going to set this to 255, which is our max. But instead of just keeping writing 255 and later on in code, we can just use this max PWM, pull it up really quick. And if we actually want to change our top speed to go slower, we can set that. So I'm going to say int again. I'm going to say max. I'm going to put this as uppercase, full uppercase. You can do whatever you want, but remember you have to keep the same syntax all the way through, right? Whether it's maxed, if you called it, whatever. So I'd highly suggest following along and doing exactly what I do, but that's totally up to you. So this is going to be our max speed. I'm going to label this as max speed, right? And so we can change this later on if we want to, but for right now, we're just going to leave it as max speed this, right? All right, and so that essentially has established all of our variables, and we've named all of our variables. Now we can go in, and now we can establish our first setup. And that's where we set up all of our pins. This is where we're going to end up setting up the pins for the joystick, pins for the H-bridge, the joystick or analog. So we don't have to set those up. The only things we have to set up are digital pins, which is all of those 6 pins for our H-bridge. And so we're going to end up with for the motor controlling. So we're going to end up jumping down here and set up. All right, so there was some issue with my video. I ended up losing everything past this where I actually filled this out and walked through this with you and typed this all in. But I lost that video, and instead of just redoing it, I'm just going to walk you through. We just left off with the max PWM, and we were jumping down in the setup, where the setup looked like this. Control X to cut. It just was that setup, and then we had the void. Well, we didn't have to do anything for our joysticks inputs, the analogs, because those are already established. They're waiting for data to come in. But we do have to set all the pins for the output of all of the digital pins that we had plugged in. That were the ones up here, the ENA, 1, 2, and then ENB, 3 and 4, for the direction. And so we have to do that. And that consists of that common pin mode in which we used, where we had established the pin and what that pin is. Output, and then the other pin. So we had to do that for all of those pins that we have plugged in. And the next thing we would want to do is, because we don't want to fire this thing on and have it just like move because there's data left over, or it just finds random numbers to throw in for those motors or whatever. We want to ensure that those motors are off. There's 0 duty cycle to the ENA and ENB pin. So that's an analog right with a 0 instead of, like, you can put a 225 here to that 0 to 225 range for those analog right, or these ENA and ENB pins, but we're just going to write to those pins 0, nothing. Don't do anything. So that's our basic setup. Just make sure that you have the pin out and a basic write to those pins for a duty cycle of 0, all inside these little curly brackets. The next thing that we have to do is to organize our code a little bit better. We're going to do something that we haven't done before. We're going to end up creating our own function, our own void setup, or our own void loop, or our own little function. And in this case, it's going to be a void. And this void is just going to be a little motor driver that takes in and outputs data for values. And so how we do that is we can do void, we can do ints, we can call it whatever. So you end up with saying void, like we do in a setup or a void loop right down here. We're going to say void space motor or drive motor with the uppercase M. And then if you hit a space and you end up with these brackets, I'm just going to delete this quick. Control X. It doesn't have anything. It's not even lit up orange, so it actually isn't a function yet. And until we do this, does it actually establish, hey, you're a function and your function's name is drive motor, right? And in this case, before we've left them blank, like here in setup, but we want to have input and output data into this function. And so we have to establish, want to put direction 1 and direction 2, and then the en to this. And the reason why we're writing it like this, where we have an integer this, integer that, integer this, and then a value, is we want to use this for all directions of this input right here from this. And then we want to output it to this. And so we don't want to write that multiple times inside of our loop. But if we just write this and store some variables and then reuse that for the actual motor driver itself, when we apply left and right, 255 negative, 255 positive, right? Whether it's forward or reverse direction or stay still, it makes our code a lot simpler and easier to look at and to actually program using this function that we're going to make. And so we end up having these variables in here that we're going to use down in our code that will eventually plug in and call up this in our loop so that we can have this data run around in the background, right? And we'll just use this function. So to start with, we established those brackets, just normal brackets, and then you have your curly brackets. And so it looks like something like this. When you start, you'll just have void motor this, comma, this, comma, this, comma, this, and then you put a curly bracket, and then we can do our said run this program with these variables, right? And so we establish an integer m equals val, and then we're going to use that val, and we're going to have, hey, if m is greater than max PWM, set it equal to max PWM. And what this is doing is capping if needed. So it's capping it. So if we see in parameters over m, our m parameters are over this, it'll just set it m to max. And so that comes into how we set this, because if we had this at like 155 and in our input here we translated this from one whatever, because this goes 0 to 225, and then we mapped it to 225, or sorry, 0 to 1023, and we mapped it, right? If we're seeing values that are over that, it's just going to automatically write to our max PWM, right? That value is going to, right? And so that's where this little if statements come in for the maxing, the statements to max our cap, right? Our speed. That's all that's doing right there. So those if statements for forward or back, max speed, how much input we're putting into it, right? And then we're going to jump down here and we're start our first if statement. And remember, an if statement is, if I'm going to type it out here quick, don't type when I'm typing, but if, right, it's got a condition and a statement, excuse me. It's got a condition and a statement. That's how ifs work. And so in this case, if m is greater than 0, move forward. So if m is greater than 0, it's positive. It's a positive number. Move forward. So then we're going to digitally write to the direction N1 high. So that's the pin forward, right? And then we're going to digitally write to the other pin, the other direction, low. Don't use that, right? And then digitally write M, the said speed, right? And then that's it. But if it doesn't do that, and we have else if, so if this isn't true, else if m is less than 0, so if m is negative, the magnitude is negative, it's going to go in reverse. So then it's going to set that direction N1 to low and use the other direction, right? Digitally write N2 high on. Okay, so it's going to send it. So it's just flipping the polarities one direction or the other direction, right? This is forward, this is reverse, and then it's going to send a negative m to that as an en, hey, go this speed, right? Okay, and then if anything else, so if these two conditions aren't true and it's just else, remember else statements don't have a condition, it's just say, hey, if anything else, write them both off. This is just saying don't move at all, just don't move. So don't move in a direction, turn it off in both directions, and put our en pin to 0. That is all this is doing. So we can take in this data and easily write it to our H bridge. All right, so the next thing we have to do is do the mapping from this to our H bridge. It's because we have that 0 to 1023 from one direction, and we have 0 to 1023 from the other direction. And we start in the center somewhere around 512. We have that dead spot that we want to know that the center is, and we kind of want to break that up on each side. So we want to go one direction. So if I move this one way, boom, and move this the other way, boom. We want this to read 0 in the center, negative 255 one direction, and then positive 255 in another direction. Or in this direction, we could have 0 and then positive 255 in one direction and negative 255 in one direction. So we kind of want to map that those potentiometers which way into those two categories, either negative in one direction or positive in the other direction. And so that's what this stick to PWM mapping is. So that's where I'm talking about this negative 255 here in this comment, near zero, right? And so we're going to start with an int. We're going to call it stick to PWM space. Make sure you write this as you see it here. And then we're going to, again, put something in those brackets, right? And we're going to do an int raw and an integer center. And then we're going to have the curly brackets on the outside. And in that curly brackets, we're going to establish an integer, call it v, and set that equal to raw minus center. And then close that. All right. And then we're going to go into an if statement. And this statement is purely for our tiny little dead zone. So we can treat it as zero. We want to have an absolute value that this thing is zero in this area, right? And so if the absolute value of v is less than or equal to dead zone or dead raw, sorry. I think I called it zone at some other point, but it doesn't matter. I call it raw in this code setup. Dead raw returns zero. So all that's saying is if it's less than or equal to this absolute value of v, which is raw minus center, is less than or equal to the dead raw, then we just return zero. So that we have where we have it in the center here and just a little movement each direction, it's always zero until it gets past a certain point. Then it starts actually recording or taking in data, right? So that's all that's doing that if statement. And typically, you could write an if statement. I don't know if we've seen this. Yeah, we did see this up here. Typically, right, if you say tab if, right, and you can say condition, right? Hold on, let's see if it pops up. If I say if, it normally pops up with the condition, right? Okay, so if I'm just v, sorry, give me a second here. We have this condition, so I'm just going to say generically v equals v or whatever. So you have some condition or is equal less than or equal to zero. Don't write this. You'd have this curly bracket like this, and then you would state your statement. So if this condition is met, do this thing. And you could down here say return zero, right? And then close that like that. And then you jump out of the if statement. But in this case, there's a million different ways to write this syntax. You can actually, instead of doing that curly bracket, because it's one simple little thing, you can just put it right behind it. Return zero. So we haven't really wrote it like that before, but we've written if statements with the curly brackets. But you can write it just like this with if this condition, do this right here. And if you have to do a large thing, you'd use the curly brackets. But in this case, we can just write it as if like right here with spaces and just spacing out the actual, that was just an example. Don't write that. We can just write it as condition and then statement right here. So just wanted to point that out because we've done it the other way. I don't think we've done it this way. If it's super simple, you can do it and follow it up like that. All right. So we have that if absolute value of v is less than or equal to dead raw, stay zero. So that's just saying, hey, we have this 0 points somewhere in the center of our joystick. Keep that dead. We don't want it. We just want you to return zero. All right. And then if this statement, which is v is greater than 512, right? V equals 512. This is just for extreme, like out of range values we might get, right? And the same thing here. If v is Control Z is undo, but v is less than negative 512, return 512. So that's just dealing with everything. The joystick itself isn't perfect. Nothing's ever perfect. The math isn't perfect. But so this is just to establish, hey, if it goes out of these range, just make sure that it's 512, right? All right. And so then after that, we're going to establish a long PWM. We're going to establish a variable. It's going to be a long PWM variable. We'll call it PWM equals long V, just like that, times by 255 divided by 512. Don't worry about this. This is literally just scaling our raw distance from the center to the PWM range. Just like that, okay? So just do that. And then we do a final clamp, belt, and suspenders. So that's what I have written down here. What this is doing is just making sure that our PWM, if it's greater than, which again, dealing with those out of range things, we might get numbers that are slightly out of range because we're doing some math here. If PWM is greater than 255, just set PWM to 255, right? Because we can't use numbers past 255 with duty cycles. All right, and the same thing here for the negative direction. If PWM is less than negative 255, set PWM to negative 255, and then close that. And then we just want it to return into PWM. So that you just have to write that. That will take care of our input data from our joystick, and then write that into duty cycle numbers in which we can use. So we have to take in that analog data, which is 0 to 1023, and then write that and map that into our negative 255 or positive 255 with our dead zone. That's all that's doing. In class, we talk about that more if you have questions. But that's our code right there. That's something we kind of haven't done before. We've established our two own little tiny functions right there. Our mapping for our drive motor for the H bridge, and then our mapping from our raw data to the 255 numbers that we need to plug into our EN driving motor. All right. So then our final thing we have to do here is our void loop. So we haven't done that yet. We're down here. I'm going to put some enters down here. We just have our void loop sitting here empty with our curly brackets empty and our basic. Put your main code here. But in this main code, we're going to do 5 things. We're going to do 5 things, and that's all we're going to do. We're going to read in our raw value from the joystick. All right. Then we're going to take those raw values from the joystick and convert those readings in and convert those to the PWM 255 positive or negative, and use the function we just created. And then after that, the third thing we're going to do is we're going to put a little statement in there. Before we did turn and invert forward, we're going to put an if statement in there that we can use to flip if our joystick feels weird, like if it's like we should have this way be turned and this way. If it feels weird, we can easily fix it in this statement. So 1 is read in values, 2 is convert those values from the joystick, 3 is use that invert things we wrote before if we want to change the direction of the joystick, right? Quickly swap out X and Y. And then 4, we're going to use the differential tank mix. We're going to create 2 little integers there so we can have one wheel go forward, one wheel go back. And then 5, we're going to send all of that data to our motor. And we're going to use the drive motor and send all that data to the H bridge. So 1, joystick, 2, converting, 3, a little invert flip if we have our joystick feel weird, and 4, the tank thing, 5, send data to motors. Just as simple as that. And so we'll start here, right in our, delete that little line, give us some space. I'm going to grab my comments over here, and what we're going to do is number 1. We're going to read in those joystick values. And to start with that, I'm going to say space. I'm going to say int x raw with the uppercase W. Or actually uppercase R, sorry. And then analog, this is the analog read value because we're reading in from the joystick. VRX. Remember how we typed it before. With the uppercase VR. And then, I got to jump out of that brackets. And I got to do this again. Int Y R W raw. Y A whatever. It's late. All right. So equals analog read with an uppercase R there. And then we're going to do the same thing. We're going to use the V R Y. We're going to jump out of this. We're going to close that. And so all that's doing is reading in our data and pumping it into this integer in which we established here. We said integer, this is our raw data, equals this read in, right? And so then next, we just have to convert that. And so step 2 is converting that using our centers. And so before, right, so we just convert our readings in and into a signal command we can use with our other motor function, right? And so in this case, we're going to say enter, we're going to say space int. We're going to store this in something called turn. We're just going to call it turn. We're going to say equals, and this is where we're going to use that stick, STI, to PWM, and it's looking for our raw and our center. Well, in this case, this is for X, and so we can just say X raw, and then we can say this is where we're going to use the center X because this is our X values, and we close that. Simple as that. And we're going to do this again for the forward. I'm going to call this FWD, lowercase. We're going to set that equal to, again, stick, PWM. It's looking for a raw. In this case, we're going to use the Y raw because that's using the Y direction. All right, and then it's looking for center, but it's looking for the center in the Y direction. So that, and we just close it like that. All right, so now that's converted. That's literally running this for the X direction and using our center, and then running it again for the Y direction and using our center. So running that twice like that right there. All right, this is where it's looping that, looking for that. So then 3, this is if it feels wrong, we can change it and ensure that it actually feels correctly on our joystick. That's just flipping X or Y, flipping the directions, or if it's inverted or if all at all. So in this case, we're just going to say this is an if statement, and we're going to do, it's going to look for the invert forward, or sorry, that's invert turn. Let's do turn first. There we go, turn. So this is, hey, looking for that Boolean. This is where we'd flip that, right? We'd say true instead of false. So if invert this, if this condition is true, which in this case we have it turned off, it's false. We're going to say turn equals negative turn. All right. So, and then we're going to do this again for an if statement. If forward, say space FWD equals negative forward. And we're going to make sure that we close this and close this. So if it felt wrong, if our thing feels wrong, either in the X or Y direction in our joystick, we can go up top here, and it's right here. We'd have to say true here or true here. And then it would actually activate this and end up flipping that for us. So that's as simple as that. So we don't actually have to flip any of the polarity in our motors or anything like that, or our pinouts or anything like that. So we can do that inside the code rather than flipping wires around. Okay. So then finally, we have our fourth one, which is the tank, the mix. We're going to send one tire forward and one tire backwards for turning. And so int, I'm going to start with this. I'm going to say int. I'm going to say left. So I'm going to do lowercase. Left, C, D, left command, right? And so just as a C, uppercase, and MD equals forward plus turn. I'm going to close that. All right. And we're going to do this for the right. So int right CMD equals forward minus turn. This. And so one wheel will move backwards, one wheel will move forwards, depending on which way we're going, right? And so it's doing that tank thing. That's all we need to do. Let's write down this little comment here. Right there. All right. And then finally, just our final little thing here, we're going to use our motor command and send that data to our motor from the PWM here. So we're going to send this data to the motor. All right. The motor controller, which is our H-bridge, right? And so we're going to call up this function, whatever we named it here. So, and then we're going to have to put in this data here too. So we're going to say space drive motor. It prompts it for me too. I'm going to say tab to use that prompt. And then I'm going to say, in this case, we're going to use the ENA pin first. So I'm going to say, because we need direction ENA, which is going to be uppercase IN1, because that's what I called that pin. I'm going to do IN2 here, and then I'm going to do ENA. That and then I'm going to say value or left command. All right, I think that's it. Yep. All right, it's been a long day. All right, drive motor, and this is what we're going to do this for the B side, which is then going to be IN3. And then IN4. And then we have to do ENB. And then again, this is for the right command. And then we want to just delay this a little bit. So we get everything to catch up. I want to delay that for 10 milliseconds. I'm going to jump out of that and close that. And that's as simple as it gets, right? If we were to not do this and not do this, this code would be a lot longer and a lot more confusing because we have to map it all inside here and then map it both sides and map our motors or send out our motor commands. And it just gets way more complicated. This simplifies it. Writing these two little simple code functions simplify our final function right here, our final loop, to this simple couple lines of code. So that's it. We can go ahead and upload, and also I'll plug it in my board here. And okay, we're plugged in. Our Arduino is connected. I'm going to say upload. And it compiled and looks correct. All right, we have no issues in our syntax. We've got all of our semicolons where they're supposed to be. Now I'm going to unplug it. And our thing's turned off. And then I'm going to end up hitting our on switch. It's going to turn on our board. And then I can use our joystick. If I push forward, our wheels go forward. If I turn, so that's forward. That's reverse. That's turn. See how one wheel is going in one direction? So I'm just moving that joystick around. That's it. We've got a working little RC car. Not so much remote control right now, but just a little joystick. So we have forward, we have reverse, we have turn. Fun stuff. All right, we'll leave it at that. So we'll go over this more in class, and I hope you can follow through and try to do this at home. If you can't and you don't have your car with you at home, we'll finish this up in class, and we'll make sure this all works. We pretty much did this in class. We might have had some issues because we were rushing through it, but we'll solve that next class period, and we'll go through this and make sure everybody's got a working car.